Welcome to the world of file handling in Python, an essential skill set for any aspiring developer. Imagine a program without the ability to remember past interactions, store data, or retrieve information. It would be like having a conversation that disappears into the ether the moment it's spoken. That's where file handling comes in, providing the crucial bridge between your code and persistent data storage. File handling empowers your programs to interact with the outside world, reading data from files and writing results back. This unlocks a whole new dimension of possibilities, allowing you to build applications that can store and retrieve user preferences, log program activity for debugging and analysis, process large datasets that wouldn't fit in memory, and much more. Mastering file handling opens up a world of possibilities, transforming your Python programs from ephemeral scripts into powerful applications capable of handling real-world data challenges. At the heart of Python's file handling capabilities lies the open function. This versatile function acts as the gateway to the world of files, allowing you to establish a connection between your code and the data stored within. Whether you're reading from a file, writing to it, or appending new information, the open function is your starting point. Let's break down its usage to understand how it works. The open function takes two main arguments, the file path and the file mode. The file path is a string that specifies the location of the file you want to access. This could be a relative path, like my _file.txt, or an absolute path, such as /home/user/document/data.csv. The path you choose depends on where your file is located in your system. The file mode, also a string, dictates how you intend to interact with the file. Do you want to read its contents? If so, you would use the mode R. Write new data to it? For this you would use the mode WOW, or perhaps append information to an existing file. The mode A is used for appending. The mode argument lets you specify your intentions clearly, ensuring that your file operations are performed correctly. Here's a simple example. Open myfile.txt R. This line of code attempts to open a file named my_file.txt in read mode. If successful, it returns a file object, which we've assigned to the variable file. This file object represents the connection to the file, allowing you to perform various operations like reading, writing, or appending data. This object serves as the intermediary through which you'll perform all your file operations. Understanding the open function is crucial for effective file handling in Python. Once you've established a connection to a file you can start reading its content. Python provides several methods for achieving this, each with its own nuances. The method reads the entire content of the file as a single string. This is useful for smaller files where you need to process the entire content at once. However, for large files, this could be memory intensive. The method reads one line at a time from the file, returning it as a string. This is more memory efficient for large files as you can process the file line by line. The method reads all lines of the file and returns them as a list of strings, where each element in the list represents a single line from the file. Choosing the right method depends on the size of your file and the way you need to process the data. It's crucial to understand these methods to optimize your file handling operations. Writing to files is the other side of the coin in file handling. This is how your programs can store data persistently, making it available for future use. Python provides intuitive methods for writing data to files, giving you control over the process. The method allows you to write a string to the file. Remember that when you open a file in write mode, W, it creates a new file if one doesn't exist or overwrites the existing file. Here's an example. This line of code writes the specified string to the file object referenced by the variable. It's crucial to remember that after you've finished writing to a file, you should close the connection using the method. This ensures that all the data is properly written to the file and releases the resources held by the file object. Section 5. Appending the epilogue. Adding to existing content. Sometimes you don't want to overwrite an existing file but instead add new data to the end of it. This is where the append mode, represented by A, comes into play. When you open a file in append mode, the existing content is preserved, and any new data you write is added to the end of the file. This is particularly useful for tasks such as logging, where you want to continuously add new entries to a log file without erasing previous records. For example, opens the file my_log.txt in append mode. Subsequent calls will add data to the end of this file, preserving the existing log entries. Section 6. The efficiency of context managers, the with statement. Managing file resources properly is crucial for writing robust and reliable Python code. This involves ensuring that files are closed correctly after they've been used, even if errors occur during file operations. Python's statement provides an elegant solution to this challenge through the concept of context managers. The statement simplifies file handling by automatically taking care of opening and closing files for you. You don't need to explicitly call the method. This not only makes your code cleaner and more concise, but also ensures that files are handled correctly, preventing potential resource leaks. Here's an example, with open myfile.txt r as file. Within the indented block of the statement, you can work with the file object as usual. Once the block ends, either normally or due to an exception, the statement automatically closes the file, ensuring proper resource management. Section 7. Navigating the unexpected. Exception handling in file I/O. File operations, like many operations in programming, can encounter unexpected situations. A file you're trying to read might not exist. You might have permission issues preventing you from writing to a file. These situations can lead to exceptions, halting your program's execution if not handled properly. Python's exception handling mechanism, using blocks, provides a structured way to deal with such scenarios gracefully. By enclosing your file operations within a block, you can catch potential exceptions and handle them appropriately. Here's how you can incorporate exception handling into your file I/O code. Python try with open myfile.txt as file print. The file you're trying to open doesn't exist, except I/O error print, an error occurred while accessing the file. Finally, this structure ensures that even if exceptions occur during file operations, your program can handle them gracefully, providing informative messages to the user and potentially logging the errors for debugging purposes. Section 8. Text versus binary decoding the data landscape. In this section, we will explore the fundamental differences between text files and binary files, and why understanding these differences is crucial for anyone working with data. When working with files, it's essential to understand the distinction between text files and binary files. This knowledge helps in choosing the right approach for data processing and storage. This differentiation lies in how data is represented and interpreted. Text files are straightforward, while binary files require a deeper understanding of the underlying data structures. Text files store data as human-readable text. They are easy to create, read, and edit using simple text editors. Each character in a text file is represented by a specific character encoding standard, such as ASCII or UTF-8. These standards map characters to specific byte sequences. Python's default encoding is UTF-8, which can represent a wide range of characters from different languages. This makes it versatile for international applications. Binary files, on the other hand, store data in a format that's not directly human-readable. They are used for more complex data types that require precise control over the data representation. They represent data as a sequence of bytes, which can represent various types of information, including images, audio, video, and more. This makes binary files ideal for multimedia content. When working with binary files, you need to be mindful of the specific data format used. Understanding the structure of the binary data is essential for accurate data manipulation. Python provides modules like and for working with binary data structures and serializing Python objects into binary format. These tools are invaluable for handling complex data types. Here's a simple example of opening a file in binary mode for reading. Python with open myimage JPG RB as file. This line of code opens the file my_image.jpg in binary mode for reading. The B in the file mode, RB, indicates that you're opening the file in binary mode. This is crucial for correctly reading non-textual data. Understanding file modes is essential for proper file handling in Python. Different modes allow for different types of file operations. This is crucial when working with non-textual data. Proper handling ensures data integrity and prevents errors during processing. Section 9. Best practices for pristine file handling. To wrap up our exploration of file handling in Python, let's distill some best practices to ensure clean, efficient, and robust code. These practices will help you avoid common pitfalls and make your code more maintainable. 1. Always close your files. This is crucial to prevent resource leaks and ensure that your program runs smoothly. Whether using the method or the statement, ensure that files are closed properly after use to prevent resource leaks. 2. Handle exceptions gracefully. This means anticipating potential issues and dealing with them in a way that doesn't crash your program. Implement exception handling using blocks to catch potential errors during file operations and prevent your program from crashing. This will make your code more robust and user-friendly. 3. Choose the right file mode. This is about being clear with your intentions when opening a file. Be explicit about your intentions by using the appropriate file mode, RW, AX, etc., when opening files. This helps in avoiding unintended data loss or corruption. 4. Use context managers. Leverage the statement to simplify file handling and ensure automatic file closure, even in case of exceptions. This makes your code cleaner and more readable. 5. Be mindful of text versus binary. This is important because the way you handle these files can differ significantly. Understand the difference between text and binary files and use the appropriate mode, B, when working with binary data. This ensures that your data is read and written correctly. 6. Consider file encoding. When working with text files, especially those containing characters from different languages, be aware of the file encoding used and set it appropriately if needed. This prevents issues with character representation and data integrity. By adhering to these best practices, you can write clean, reliable, and efficient Python code for interacting with files and managing persistent data effectively. These guidelines will help you create programs that are not only functional but also robust and easy to maintain. Section 10. Conclusion: Mastering File I/O for Pythonic Prowess. Congratulations on embarking on this journey through the realm of file handling in Python. You've delved into the intricacies of the function, explored various file modes, mastered the art of reading and writing data, and learned to handle exceptions gracefully. You've even uncovered the distinctions between text and binary files, equipping you to work with a wide range of data formats. Remember, proficient file handling is more than just a skill. It's a superpower that elevates your Python programming prowess. It's the key to unlocking the